I will be demonstrating a C++ program that will evaluate the definite integral of a given function using the Simpson's one-third rule. However, before we can create a program, we need to understand the basic principle, the formula, and the solution to this type of approximation method. Let's take a look at Figure 1 graphical representation of Simpson's one-third rule. Simpson's one-third rule is a method for numerical integration, the numerical approximation of definite integrals. Specifically, it is the approximation for n plus 1 from x sub 0 to x sub n, bounding n equally spaced subdivisions where n is an even number. N is the subinterval segments or subdivisions. Simpson's rule can be derived by approximating the integrand f of x, the blue curve, by the parabolic or quadratic interpolant px, the red curve. These are the subdivisions, and this is the h, or the step size. H is computed by b minus a divided by n, that is the step size or length size. We have a space between the upper side of px and the actual curve of the function of x. This space represents the error of this method. In order to reduce the error, we need to increase the number of segments or divisions. We should give a larger number of n in order to have more accurate value. We may not get the exact value, but we need the most accurate value. The larger the number of segments, the more accurate the value of the integral. Simpson's rule is applied to each subinterval or divisions or segments, with the results being summed to produce an approximation for the integral over the entire interval. The formula used in Simpson's one-third rule is approximately equal to h over 3 times the quantity f function of a, the lower limit, plus 4 times f of x sub 1 plus 2 times f of function of x sub 2 plus 4 times f function of x sub 3 plus 2 times f function of x sub 4 until 4 times f function of x sub n minus 1 plus f function of the upper limit b. The integral can simply be put in the following notation. The integral is approximately equal to h over 3 times the quantity f function of x sub 0 or the lower limit plus f function of x sub n, the upper limit, plus the summation of 4 times all the terms with function of x with subscript of odd numbers 1, 3, 5 up to n minus 1. N is even, minus 1 will be odd, plus the summation of 2 times all the functions of x with even integers 2, 4, 6. This is the final form that we will be using to create the program for Simpson's one-third rule. The purpose of the C++ program is to evaluate a definite integral by Simpson's one-third rule. The algorithm is as follows. Number 1, given a function f of x, enter the values of lower, upper, the number of segments, and the position. Do the integration for f lower and f upper limit. Set h is equal to upper minus lower divided by n. This is the step size. Number 4, set sum is initialized to 0. And then begin the loop for I is equal to 1 until n minus 1. Set x is equal to a plus I times h. If I is even, or if I is divided by 2 and there is no remainder, then set sum is equal to sum plus 2 times f of x. Else, if it's odd, then sum is equal to sum plus 4 times f of x. That will end the loop. And then number 6, set a sum is equal to sum plus f function of the lower limit plus f function of the upper limit. And then step 7 is set integration is equal to the sum times h divided by 3. That will end the program. And this is the flowchart. We'll start and enter the values, the h, initialize the sum, and then do the loop. And then if it is even, do this equation, and if it's odd, do this equation, and then next I, and if I is still less than n minus 1, do this loop, and if I reaches n minus 1, then sum is equal to sum plus f lower plus f upper, and then integration is equal to sum times h over 3, and then print integration. There are two parts of the C++ program: to solve the definite integrals of transcendental equations and to solve the definite integral of the polynomial equations. Let's proceed to the C++ program for transcendental equations. Let's move on to the code block. Now, to write the program, let's write a simple description for the program, hiding it with this two slash. Okay, C++ program for Simpsons 1/3 rule. We will include a hashtag include iOS stream. This header defines standard input-output streams, which includes console in and console out. Including this header may automatically include other headers such as iOS, iStream, and output stream. The CMath declares a set of functions to compute common mathematical operations and transformations like trigonometric, exponential, and logarithmic functions. Math.h is similar to CMath. We just include it. And then hashtag include IOManip. This is the parametric manipulator that includes set width and set precision. Conio.h is a header file used mostly by MS-DOS compilers to provide this conio is to provide console input and output, which includes clear screen, get ch, and return. Standard input-output. The H, this library uses what are called streams to operate with physical devices such as keyboards, printers, terminals, or with any other type of file supported by the system. Standard library. The H is the standard general utilities library, includes environment functions like abort, exit, and integer arithmetics. Using the namespace standard means make all the things available under the standard space. This line is the declaration of the variables which are used in the program. Double are integration, the step size h, precision p, x, value of x, f of x, Simpsons, lower, upper, and sum is initialized to 0. And the integers are I, m, multiplier, and number of segments. The y is the exponent, and iterative is set to 0. And then double is the f is declared as double, and the function double x also. And this is the equation double a, and it will return a. When f is being called inside the program, it will return this equation and solve for the x function of x. The int main is necessary for every program. From this line onward, the program body starts. Let's print this cout will print Simpsons 1/3 rule, the title of the program. Let's print also the solution for this equation. And then we will print out also enter lower limit of integration. This is slash n will provide another new line. Enter lower limit of integration, memory save to lower. Enter upper limit of integration, will save to upper. These two slashes will hide any words after or character after these two slashes. And then cout also print out enter number of segments will be saved in n. Precision will be saved in p. This set cout precision will call whatever the entered p, and then fix. This will fix the precision p to the desired decimal point. And then we will print out also tabulated results, end of line, semicolon. Semicolon will terminate every line statement. And then print out again. Set 8 is the width for the iteration, set 8 for x, f of x, and Simpson's rule for set width for 25. We will print also a line below the description of the table. And then let's proceed to the 8's. We will set 8 is equal to upper minus lower divided by n, that is the step size. The sum is equal to f of the lower plus f of the upper. This is the summation of the lower limit and the upper limit. And then f of x, we will set it as f function of lower. Then the multiplier is m, which will be printed here. We will print all the values, either lower, function of the lower limit, the multiplier, and the function of x. Okay, now do this loop for I is equal to 1 and I is less than or equal to n minus 1, I plus plus. So I plus plus will increase I with every repetition. Where x is equal to lower plus I times 8. If I is even, or I modulus 2, I divided by 2 has no remainder, then we will perform this equation. Sum is equal to sum plus 2 times f of x. F of x Simpsons is equal to 2 times f of x. The multiplier m is 2. And then else, if it is odd, if there is a remainder, then sum is equal to sum plus 4 times f of x. F of x is equal to 4 times f function of x. The multiplier for add i's is 4. And then iteration will be increased by 1 every repetition of the process. And then we will print all the values, either value of x, function of x, the multiplier, and of course the f of x of Simpsons. While we will repeat the process while I is less than n. When I reaches n, then we will do this equation. F of x is equal to f, the upper limit, and the multiplier is 1. This is the last iteration. Then we will print again the n, which is the last iteration, the upper limit, the f of x, which is the upper limit, and the multiplier. This is the upper limit, and then the function of x, and then the upper limit and the function of Simpsons, which is also the same. And then finally, the integration is equal to h over 3 times the sum of this loop. And then we will print also a line below the table. We will print out a set W39 for sum, and this is the sum of the Simpsons 1/3 rule. We will create a space between them. We will print out the value of integral is the integration computed here, and this get ch, open and close parenthesis, semicolon. This will hold the terminal until we press any key. So let's take one problem. Let's build and run this program. Okay, so we are prompted to enter the lower limit of the integration for the exercise 2 problem number 6. The lower limit here is 5, and then the upper limit is 35. The n is assigned as 12, and we will assign precision as 6, and we will have the output of the value of integral is 812.045313. We have here the iteration from 0 to 12, and then x is from the lower limit to upper limit, the function of x computed, and then we have the multiplier, and we have the sum of the Simpsons. As we notice, 4 is being multiplied with those odd integers, and 2 is being multiplied with 2, 4, 6, 8, 10. Okay, we will take another problem. Okay, we'll go back to code block, and let's highlight this transcendental problem. Okay, let's hide this first equation, and then let's give way to the y. Okay, and let's hide this equation. Now let's build and run these transcendental equations, which is e raised to negative x raised to y divided by 2 all over square root of 2 times pi. So this is transcendental equation. Let's build and run. Let's take a look at the terminal, and then the user is prompted to input the value of y. So we will put 2 as the value of y exponent, and then we will have a value of the lower limit as negative 2.15, and the upper limit of 2.9. We input n as 4, and the precision as 6, and we will have output. The value of integration is equal to 0.960788. We have the iteration here 0 to 4, the excess, and then the function of x, the multiplier, and the Simpsons 1/3 rule. So that is the transcendental equation. Okay, and we will proceed to the second program, which is the C++ program for 3rd to 10th degree polynomials. Okay, the same is included here. I just hide the first program with this asterisk, and then close it with asterisk slash, and then activate this when I remove the asterisk. And then we include the same header with the first program, and using namespace also, and we declare the integer as I, degree, and m, and the iteration is initialized to 0. Double is the coefficient. We assigned it as 12, but the maximum is 10. And then the h, the lower limit, upper limit, x, function of x Simpsons, and then the p, precision, the sum, and the integration. We will start the program by int main, open and close parentheses. We will print out again the title of the program, which is Simpsons 1/3 rule calculator. We will print out this program estimates the integral of 3rd to 10th degree polynomials, end of line, semicolon. And then we will be prompt to enter the degree of function. We have 2 spaces here, and then the degree of function will be saved in degree. If degree entered is greater than 10, we will print out the degree you entered is out of range, and the program will be terminated. Else, if the degree is less than 3, then we will print out the degree you entered is out of range, and the program will be terminated. Else, for I is equal to degree, and I valid from 3 to 10, and I is greater or equal to 0 until I is equal to greater or equal to 0, then I minus will decrease the value of the deg. Enter coefficient of x raised to the degree, and then a sub I, the degree also, I, and then it will save here. If you enter 5, then 5, 4, 3, 2, 1, 0. And then C out also, enter lower limit, will be saved in the lower, upper limit will be saved to upper, enter the number of segments will be entered to n, saved to n, and then the precision will be saved to p. Set the precision p will be called the desired precision, for example 4, 5, 6 decimal points, and then this will fix the precision required. And then set h is equal to upper minus lower divided by n, and then we will calculate and tabulate the results. We will print out slash n, this is double line, new lines, tabulated results. We will print out again the descriptions, item x, f of x, Simpsons 1/3 rule, and then the line below it. And then we will set x is equal to lower, f of x, we will compute the lower to this equation, and then f of x is equal to 1 times the function of x. Sum is equal to f of xs. The multiplier is m is equal to 1, and we will print out also set w and the values of iteration x, f of x, m, and the f of x Simpsons f of x. Iteration is equal to 1, then we will start the iteration is equal to 1. Here the iteration is at 0, and then do if iteration is even, iteration divided by 2 it has no remainder, then set x is equal to x plus 8, and then do the f function of x for this equation up to a sub 0, and then f of x is equal to 2 times f of x. Sum is equal to sum plus f of x. Sum is f of x, sum plus f of xs, fxs. M, the multiplier for this even iteration is 2. And then C out the values of iteration, value of x, f of x, the multiplier, and the Simpsons f of x. Else, if the iteration is odd, then we will perform x is equal to x plus 8, and then perform the f function of x for this equation, and f of x s is equal to 4 times function of x. Sum is equal to sum plus f of x. The multiplier for add is 4. Then again, we will print out iteration x, f of x, the multiplier, and the f of x Simpsons. The iteration will increase by 1 every repetition of the loop. While do this process while the iteration is less than n. If I is equal to n, then let's do the last iteration, the upper limit. X is equal to x plus 8, f function of x, and f of x is equal to 1 times f of x, and sum is equal to sum plus f of x, m is equal to 1. We will print again set of x, and then the parameters are the values computed are the iter, and then the x, f of x. We will print also the multiplier and the f of x for Simpsons, and we will print also a line below the table, and we will print set 39 sum, and the sum will be called for the process. Okay, finally the integration is equal to h over 3 times the computed sum, the total of the f of function of x for the Simpsons 1/3 rule. We will print a line. We will provide a line between the table and this line. C out, set w, set with 35. The value of integral is the integration computed, and get ch, open and close parentheses, semicolon. This will hold the terminal until we press any key. And we will try to build and run this program, and this program will estimate the integral of 3rd to 10th degree polynomials. We will use the example exercise number 2, problem number 6. Let's use 5 as the degree of the function, and then the coefficient of x raised to 5 is 0.00026, and then the coefficient of x raised to 4 is negative 0.02635, and the coefficient of x raised to 3 is 0.99555, and the coefficient of x raised to 2 is negative 17.34855, and then the coefficient of x is equal to 137.59, and then minus 358. The lower limit is 5, the upper limit is 35, the segment is 12, and the p is 6, and we will have the result. The value of integration is equal to 812.045313. Okay, so this is the program for integral of 3rd to 10th degree polynomial. This is the exercise 2 number 6. Okay, and this is the solution for 3rd to 10th degree polynomial second program. Okay, this is the first program. Okay, comparing the first program and the second program, we have similar tabulated results, only that the first solution has embedded equation. Though it can solve both transcendental and polynomial equations, it can only solve that specific embedded function. The user only prompted 4 parameters, the lower, upper limit, and then the number of segments 12, and the precision 6. While the second program will solve 3rd to 10th degree polynomials, all the coefficients are required to be inputted, plus the number of segments and the precisions, and as well as the lower limit and upper limit. The value of integration is the same for both the program, which is equal to 812.045313. Okay, if we set the number of segments to 220, then we will achieve the exact value of 812.1. Even if we increase to more than 220, the value of integration is always 812. Okay, which means that the larger the number of segments, the more accurate the result is. Therefore, the C++ program can solve transcendental and polynomial equations. The references are Wikipedia, MacTutor.com, Fizzwiz, Bragitoff.com, and C++.com. This concludes my C++ program. I hope this presentation is comprehensive enough to understand how to create a program in evaluating the definite integral of a given function using the Simpsons 1/3 rule.